So yesterday we determined our formula for area of any regular polygon with any number of sides. And we decided it based on the fact that, based on our area of a triangle formula. So we took our shape that we didn't know how to find the area formula for and turned it into a bunch of triangles that we do know how to find the area of. So the side length formed the base of the triangle. The apothem is our new term. It forms the height of the triangle. And then we multiply that by our number of sides. This is 1/2 ASN. Multiply that by our number of sides because we decided, we saw yesterday, that how many sides there were determined how many triangles were built. Since there were 6 sides, there were 6 triangles that got made. So that is our area formula. Now, the thing that's going to happen is that we have these pieces that we aren't going to know. So since this is a triangle, we're going to call back some of our old friends of our trig and our Pythagorean theorem in our 30, 60, 90, and 45, 45, 90 patterns. Most of the time, you're going to see us using trig to solve for the piece that's missing. Most of the time, you're going to see sine, cosine, and tangent get used to solve for whatever's missing. So what you're going to see is that we're going to have the apothem, but we're not going to have the side length, and we're going to need trig to solve it. Or we're going to have the side length, but we're not going to have the apothem, and we're going to need trig to solve it. So that is kind of one of the pieces to this puzzle is using these tools to solve for our missing pieces within the triangle. So now there is one more missing piece to this, and that is in order to use the trig, we need to get an angle. So we're going to get that angle by finding something called a central angle. A central angle. It's called a central angle because it's going to be the angle that's at the center. It's going to be the angle that's at the center. And it's going to be within our triangles. So that when we use the trig, we have an angle that we can use to get the trig. So that's the last piece of this. So let's talk about that very quickly. To get our central angle, we need to go all the way around the circle because we can go around the entire polygon. How far is all the way around the circle? 360. 360 degrees. And so in order to figure out what the angle in the triangle is, well, how many triangles are there? It's determined by how many sides there are. Because remember, each side forms the base of one of the triangles. So one other quick formula that you will need to write down is to get this central angle. The way we're going to get that central angle is to take 360 all the way around the circle. Right? This would be all the way around. That would be 360. And we're going to divide it by our number of sides to get just the angle here in the center of that triangle. We're saying each triangle is going to have this angle of 360 divided by that number of sides. So make sure you get this written down along with the rest of those pieces that you just wrote down. So there's going to be a lot of moving parts to this, but we'll do 3 examples here today, and you're going to see the process is going to stay the same. The problems are going to flow the same way every time. There's going to be kind of 4 main steps, and those steps aren't really going to change. They're going to remain the same every single time. So here we go. Four different steps to the process. You'll see the triangle over here that is off to the side so that we can do our work in solving for that missing piece separately. So as I said, there are kind of 4 main steps to each of these problems. Step 1, we're going to write down all the things we already know. We're going to write down all the pieces of information that we already know. Well, we know already that what kind of shape it is. What shape is it? It's an octagon. So since it's an octagon, that means it has how many sides? 8 of them. So there's one of the things we know already, is our number of sides. Our number of sides is 8 because it's an octagon, and an octagon has 8 sides. Remember that number of sides is in our formula because that's how many of these triangles are built. There's one triangle for each of these sides here. We also know another piece of information. There's something else there that is 8, which is my apothem, which is serving as the height of the triangle. So this apothem here is 8. And so all I need to solve for is my side length. So side length is the missing information that I need. So now we move on to step 2, which is to get my central angle. Step 2 is to get my central angle. To get my central angle, I'm going to take 360, which is all the way around, and divide it by our number of sides, which is 8. So we have 360 divided by our number of sides is 8. That will give us 45. Now here's the catch. There's a catch here, but this catch stays the same every time, which is that 45 will give me this angle right here. So I know this angle is 45 degrees, but I don't want that angle. The reason I don't want that angle is because it won't help me in solving the actual right triangle that we're going to be solving. So to get the right triangle, I just want this little piece of the angle. Luckily, all we need to do to get that little piece of the angle is cut this in half. It splits that entire triangle down in half. So we're going to take that 45, divide it by 2. That's going to be 22.5. So the central angle here that we're interested in is 22.5, 22.5 degrees. So that is our angle. And now that we have that angle, step 3, we're going to solve for our missing piece. So we already know that this is 8. That was our apothem. We already know that this is 8. So we can use that to solve for this piece right here. So we're kind of zooming in and we're solving for that piece using our right triangle stuff. So using our right triangle stuff, we know our adjacent and we're trying to solve for our opposite. So sine, cosine, or tangent, it's going to be tangent because we know our adjacent, we want our opposite. Opposite and adjacent, that's tangent's job. So we have the tangent of our angle. That's 22.5. And opposite goes on top, adjacent goes on the bottom. So that's our fraction. To get rid of our fraction, we're going to multiply by 8. So our 8's cancel, no more fraction. Is x by itself? All right, x is by itself, so we have it solved for. Now, there's one more piece to this. There's one more piece to this. Once again, there's a little catch. So I have solved for this. I can put it in the calculator. It'd be about 3.3. However, if I take this and I zoom out over here to the octagon, here's what I just solved for. This little sliver right here. Is that the entire side length? It's half of it. So what do I need to do to get the entire thing? We're going to multiply by 2. So to get our side length, we're going to double that 8 tangent of 22.5. Which is 16 times the tangent of 22.5. 2 times 8 is 16, and then we keep the tangent how it is. Now, here's something else you'll see me doing. You're going to see me keep the answer as I go through the calculator stuff. I'll be keeping the answer as exact as possible. So on my paper, I'm going to put in 16 tangent of 22.5. It's going to be about 6.6. So on my paper, I'll write about 6.6. And I'll put that over here as my side length. But in my calculator, when I start to type things in, I'm going to keep that stored in my calculator, this decimal. And when I go to work through the rest of it, so in other words, I'm not going to take the 3.3 and double it. I'm going to take that exact answer and double it. So I'll take the 16 tangent of 22.5 and have that value. So now I have it. I'm storing it. I'm going to use it. I'm not going to type a new 6.6. I'm going to take this same number when I plug it into the rest of the formula. I'm going to take it with me. So if your answer, when you put it into the calculator, is a little bit off rounding wise, that's why. It's because you rounded before you put it in. But now we move on to our last step. Now that we have, and this is the easy step, because now we have solved for all the pieces. So all we need to do is we need to plug it all into the formula. So 1/2 our apothem, which is 8, times our side length, which is 6.6, times our number of sides, which is 8. So we're going to take, and I'm going to round this to 3 decimal places here to give me 212.077. Units squared? Yes, it's an area. It's an area, so it's going to be in units squared. Right, now I know there are a lot of pieces, there are a lot of moving parts to that problem. But keep in mind, something to keep in mind as we go through more examples is watch that those moving parts are going to stay the same every time. This process is not going to change very much from example to example. Okay, that's the good news of these problems. So let's do one more and kind of recap and watch how the steps stay the same. We have, how many sides? One. And if you don't know, you can count 4, 5, 6, 7, 8, 9, 10. So it is a decagon. So since it is a decagon, that gives us one of our pieces right there. We're still using the same formula. We use the same formula every single time on this. Here's our apothem, side length, number of sides. How many sides? We just counted them, it's 10. Then we have our side length. What is our side length? 7. The side length is what we were given. So this time the apothem is what we're looking to solve for. Last time we knew the apothem, we wanted the side length. This time we've got the side length, we're going to get to the apothem. So that's our step 1. We wrote down the information we knew. We wrote down what kind of shape it was. So step 2. Step 2 is going to involve getting our missing piece. We're going to get the central angle. Remember that the central angle comes from, here's the triangle that's getting built. Here's the apothem that I'm looking for. Okay, that is this triangle over here. I'm zooming in to focus on the triangle stuff. So step 2 is to get my central angle. To get the central angle, well, I'm still going to take 360 and divide it by my number of sides, which is 10. And that's going to give me 36. But again, that would give me this entire angle. I don't want that entire angle. I want to take that and cut it in half to get just this piece, which is 18. So that angle right there is 18 degrees. And that will help me with the right triangle that I'm actually looking for. Oh, careful, zoom out again. I've got this piece, but it's not 7, because look, zooming out, here's where that piece is in the actual decagon. So that's not going to be 7, that's only halfway. It's halfway again. So since the whole thing is 7, I'm going to cut that in half. And that is my opposite. I'm trying to solve for the adjacent. So because I know opposite and I want adjacent, it's going to be tangent again. Because I'm still just interested in opposite and adjacent. Tangent of my angle is 18 equals my opposite goes on top, my adjacent goes on the bottom. So to solve, we're going to get rid of our fraction. We're going to multiply by x on both sides to get rid of our fraction. Equals 3.5. Is x by itself yet? Oh, man. Well, that means we got to divide. By our tangent of 18. So we have 3.5 over tangent of 18. So I'm going to be putting in the calculator what that is. Now on my paper, I'm going to put that rounded decimal at 10.8. So 10.8 goes on my paper. 10.8 goes on my paper. But in my calculator, I'm going to keep that exact answer stored in. So I'm not going to type in the 10.8. I'm going to take it. I'm going to take that answer I just got and I'm going to multiply it by the rest of the pieces. So we have our area formula. Our number of sides is 10. Our side length here is 7. Our apothem that we just solved for is the 10.8. On my paper, but in my calculator, I have that big long decimal still stored when I multiply the rest of it out. Which gives me, I'm going to go to 3 decimal places again, 377.016 units squared. Right? So I want to recap what happened to give you the big picture that's going to keep consistent every time. To recap, step 1, we wrote down our formula. We've worked on all our missing pieces. Step 2, we found our central angle by taking 360 divided by number of sides. Once we had that central angle, step 3, we used our trig to solve for our missing piece that we wanted. And then once we had that missing piece, step 4, we plugged it into the whole formula and got our answer out. All right, we're going to do one more. So questions before we do that? Okay, one more. And this one's going to be shorter. For reasons that you'll see in just a minute here. So first off, we'll write down our area formula, but we're also going to put down what shape it is. It is a triangle. It is a triangle. It is also a regular polygon. It's an equilateral triangle. So it is a regular polygon, so we're going to use the regular polygon formula because we don't have the base, we don't have the height. So we can't use that formula. Apothem, side length, number of sides. How many sides? 3. And do we know our apothem or our side length? It's our apothem, and our apothem, remember, is the height dropped down, which is 6. So our apothem is 6. We want our side length. Okay, so that's step 1. That's all the information that we've got and that we need. Step 2, get our central angle. I'm going to give you a 30-second head start in getting the central angle. Okay. There it is. Remember, it needs to get cut in half. And now that we know that it's 60, that's great news for us. That's great news for us. That means that we have a 30, 60, 90 triangle. Now remember that if you don't know your 30, 60, 90 pattern, you can use your trig. You can still use tangent to solve this one, but watch how much faster the pattern is. Because the pattern says, take my short leg, which is 6. So to get my missing piece that I want, I'm going to take that short leg of 6 and multiply it by square root of 3. That's my pattern. And we're done. Well, not quite. To get my short leg, I'm actually going to take that 6 square root of 3 and I'm going to double it because that 6 square root of 3 is only this piece. So that'll be 12 root 3. So that's where it goes. And so now our last step, 1/2 our apothem times our side length times our number of sides. Our number of sides is 3. Our apothem here is 6. Our side length we just solved for is 12 square root of 3. So I can get an exact answer out of that. That would be 108 square root of 3. But I can also get a rounded answer out of the calculator, which would be 187.061 units squared. So again, I followed that same process. Write down the information you already have, get your central angle, figure out your missing piece, plug it all in. That's the steps that you want to follow each time.